Okay, this is the continuation of lesson 7.9. We're going to identify equivalent expressions. So these are on page 407. You don't have to write it down. It is there for you. I wrote it down so you could read it better on here. Each train on a roller coaster has 10 cars, and each car can hold 4 riders. The expression 10t times 4 can be used to find the greatest number of riders when there are t trains on the track. Is this expression equivalent to 14t? Question mark. So we have to see if when we combine terms and we use our properties, if this is going to be equal to 14t. So first, we are going to write down what we know, which is 10t times 4. Then we can use the commutative property of multiplication. Okay, here we are going to separate all these variables, 10 times t times 4. Then we are going to use the associative property to, after we commute these two numbers around, change the t and the 4 so that you have your numbers right next to each other. You can put parentheses around the 4 and the 10. That's the associative property. Then multiply 4 times 10 within the parentheses. You get 40 times t or 40t. Is that the same as 14t? No, it is not. And one way to check that, to check to see if it's the same or not, is going to be to substitute a variable. So maybe pick something like a small one, like 2. If you have 2 trains with 40 spots on each train, 2 times 40 is 80. Whereas if you have 2 here, 2 times 14 is 28. So these are not equal. These expressions are not equal. So basically what you're going to do is combine terms as make it as small of an expression as you can, and then compare the two and check it. That is the goal of today. So that's what we're going to be doing. Here's another example. You don't have to write this one down. It's on page 408 in your book. You might want to turn to page 408 so you can do yours along with me. It's up to you, or you can just watch and we'll do a couple together so you have some in your notes. Use properties of operations to determine whether the expressions are equivalent. So these are the two expressions that we are checking to see if they are equivalent. The expression 10y plus x is a sum of two terms. So we want to rewrite this one as a sum of two terms also. All right, so we're going to rewrite it. We write it down just like this. Then we're going to use our properties again to change things around and make it as small as possible and combine so that we can get it into just two terms like the other one. We want two terms. Use the commutative property of addition to rewrite x plus 3y. So we are rewriting that, so we are getting these two changed around so that I can move. So that's the commutative property. We change them around. Then I'm going to use the associative property to change where my parentheses are. Okay, as it doesn't help me because I can't combine a y and an x, but I can combine these two y's. So let's do that. 7y plus 3y is 10y plus my x that I have up here. So now I can see that 10y plus x is equal to 10y plus x. We compare those just by looking at them. You don't need to put numbers in there because they look exactly alike. So after you combine terms, if they look alike, then you have two equivalent expressions. All right, this one is also on page 408. Here's just another example, so just follow along with me. We're going to compare these two. Is 10 times the sum of m plus n the same as 10m plus n? So let's see if those are the same. It says the expression 10m plus n, that's this one, is a sum of two terms. So rewrite 10 times m plus n as a sum of two terms. So we are going to use the distributive property here. So we copy this one down. We distribute the 10 across both of these numbers. We get 10m plus 10n. 10m plus 10n. Now I'm going to compare. Is that the same as 10m plus n? So I am looking at this. The 10m is the same, but this one's 10 times n, and this one's just plus n. So this one's going to be always larger than this one would be, and I can check that by putting a number in for each of those numbers. So I just picked a couple that were small. I could put other numbers in here, but for M, I tried a 2, and for N, I tried a 4. So here, for M, I put in the 2, so 10 times 2, plus 10 times the N, I put in my 4, 4. When I add those all up, I get 60 on this side. Then I'm going to try it over here. 10 times my 2 plus my N, which is 4. 10 times 2 is 20, plus 4 is 24. So these are not equal. These are not equal. That's how we can compare those. All right, let's do a few together, okay? I'm going to do the first one. You can just watch it, and then we'll do the second couple together. So the directions say use properties of operations to determine whether the expressions are equivalent. So here I see I have 3 terms, and this one I only have 2 terms. So I'm going to combine these like terms to see if I can make these two look the same. So I'm going to take this one, and first I'm going to use the commutative property to move the 4 out front, because I noticed the 4 is out front over here. So I'm going to change that 4 and put it out front. Now I'm going to use the associative property, because these are all additions. So I can use associative property to combine 7k plus 2k, which is 9k. So now I have 4 plus 9k, and this is what I have over here as well. So I know those two are equal because they look exactly the same. Those are equivalent expressions. All right, pause your video, write these two down. And let's do the first one together. So I see we have this, and we're comparing it to cut to the 12a. Now remember that 9a is the same as 9 times a. 12a is the same as 12 times a. And so I'm going to actually write it like that so you can see it. And then when you notice that this is all multiplication, we can use the properties to move these around. So I see a is at the back here. I'm going to put my a at the back, and I'm going to flip my 3 and my a over. All right. Next, I'm going to use my, what's the one where we shake hands, the associative property to put parentheses around these two numbers, because we're multiplying and there is an associative property of multiplication. 9 times 3 is 27. So I have 27a. Is that equal to 12a? And my answer is it is not equal. If I put a 1 in here, 27 times 1 is 27. And if I put a 1 here, 12 times 1 is 12. So these are not equal expressions. So I combined the like terms, and then I tried it out, and I realized it is not equal. Okay, you guys can try this one. Pause your video and try it. Okay. Now, this one is going to be looking at the identity property. And in this one, 8p plus 0, if we use the identity property, 8 times p plus 0, it's just going to, plus 0 just goes away. It keeps the same identity. So this 8p just stays the same. However, if we multiply 8 times p times 0, whenever I multiply by 0, my answer is always 0. So for this one, it's just going to be a 0 when I simplify it, because that 0 multiplied times anything makes it 0. So these, again, will not be equal. Those are not equal. Multiplying by 0 is a lot different than adding 0. So we're going to try one more like these kind. So you can pause the video and try it on your own if you'd like. This is number 5 on page 409. Or you can just hang along and do this with me. Okay, so here, this is the one that we are going to simplify. And we're going to compare it to 16v. So here I only have one term. So I'm going to try to get this down to a small amount of terms and see if it's equal. So first I see I can use my distributive property to distribute that 3 across both of those. Okay, so we're using the distributive property. And whenever you see a variable inside the parentheses, you might want to check to see if you can use that distributive property. So I have 3 times v plus 3 times 2 is 6 plus 7v. I notice that I want to get my v's together, so I'm going to switch these two up. 3v plus 7v plus 6. Now I'm going to associate these two together and combine them. 7 plus 3 is 10, so we have 10v plus 6. Now, this is adding and this one's multiplying. If I add 6, I can't combine these terms because this one has a v in it, this one does not. So they are not like terms and can't be combined. I can't just add 10 plus 6 to get 16. So these are not going to be equal. Okay? All right. We're going to go a little bit deeper. Let's look at this one together. You don't have to write it down. It is on page 409. It's number 8. Each case of dog food contains C cans. Each case of cat food contains 12 cans. 4 students wrote the expressions below for the number of cans in 6 cases of dog food and 1 case of cat food. Which of the following are correct? So we have, so each case contains 12 cans. 4 students wrote. So we have 6 cases of dog food, 1 case of cat food. The cat food is 12, so we just have 1 case of that 12. We have 6 cases of the dog food. So 6 times the number of cases would be correct for dog food, plus just the 1 case of cat food, which is 12. So this one works. Now, is this the same as multiplying that by 12? No, it is not. So that one does not work. Then this is the next one it shows us, and I see I could distribute my 6 here to see if this would work. 6c plus 12. 6c plus 12 is the same as this one, so that one would work. This one, I have a 3, and it's kind of strange. It looks a little strange, but it's still multiplying, and we're still multiplying this whole parentheses by the 3. So I can distribute backwards as well. So 3 times 2 is 6c. 3 times 4 is 12, and we're adding those. So again, that would work for the number of cases. So this would be my really simplified expression. And then I'm just looking at these other expressions and I'm simplifying those as well to get them as small as possible and comparing them to that. And those two are equal. All right, you can try your Think Central assignment.